With a population of over 1 million, Leicestershire is a dynamic, vibrant and multi-ethnic county with an exciting future. Leicestershire is also home to University Hospitals of Leicester NHS Trust, University of Leicester and Loughborough University, which together form a strong partnership to support the BRC mission.
The university's increasing synergies with the Acute Trust have generated important infrastructure biotechnology services to underpin the mission of our proposed BRC. These include 2 new research institutes, one in structural and chemical biology, the other in partnership with the Trust, precision medicine. Other facilities include our drug diagnostics unit and the East Midlands Brithomics Pathology Node Centre, which will develop breath-based systems for molecular pathology.
Loughborough University is one of the very best universities in the UK. Sport, exercise and physical activity are in our DNA, and the academic side of that is led by the School of Sport, Exercise and Health Sciences. It was this reputation that led the school to being the driving force and national lead in the Department of Health's London 2012 Summer Olympics Legacy Project, the National Centre for Sport and Exercise Medicine, or NCSEM. The ambition of the NCSEM is to improve the nation's health through sport, exercise and physical activity.
With 13,000 staff across 3 sites, our trust is one of the biggest and busiest in the country. Our research is central to our work, and our quality patient care is underpinned by the academic excellence of our medical research with our university partners.
In collaboration with the University of Leicester and Loughborough University, we have a critical mass of research excellence and infrastructure in 3 areas, which combined cost the NHS over £20 billion a year: cardiovascular, respiratory and lifestyle-related metabolic disease. Our BRC integrates these 3 related research themes with precision medicine as a cross-cutting theme.
I had a heart attack when I was 34 and it was caused by spontaneous coronary artery dissection. I found a research study over in America, but as I connected with more UK patients, we realised the need for our own research, so that's when I came back to Dr. Adlam.
SCAD is a rare cause of heart attacks which afflicts predominantly young women, including around the time of childbirth. Our research was initiated by the patients themselves, the SCAD survivors. And with the help of the BRU and supported by the NIHR Rare Diseases Translational Collaboration, we're trying to understand the underlying causes of this condition to improve treatment for patients and to see if we can reduce the risk of recurrence.
SCAD is part of the portfolio of research where we are trying to better understand the genetic basis of common and rare cardiovascular diseases. We have made substantial progress in the last few years, identifying over 60 genes that affect the risk of heart attacks, and the translational potential is enormously exciting. We are fully engaged in this work with other NIHR structures such as the NIHR Bio Resource, as well as UK Biobank, and national and international collaborators.
Evidence suggests that sedentary behaviour is a risk factor for type 2 diabetes and CVD, and therefore it's a target for lifestyle intervention. However, there's currently a lack of experimental data. We've developed a unique experimental platform to investigate the effects of breaking up prolonged sitting. In the acute study, 5-minute bouts of standing or light walking significantly improved glucose metabolism in women at high risk of type 2 diabetes.
Over the past few years, we've invested in hundreds of state-of-the-art objective devices that are highly accurate in capturing physical activity and sedentary behaviour. During the acute study, participants wore an active PAL on their thigh, and this measures their sitting, standing and walking, so we know whether they have complied with the experimental conditions. They also wore an accelerometer on their hip, and this allowed us to track what activity they were doing in between their visits to the lab.
The big impression that it made on me was that such a simple thing could make such a big difference. The future depends on people doing studies like this and getting involved, because that's how you've benefited in the past.
In collaboration with Novartis Pharmaceuticals, we carried out a Phase 2 randomised controlled trial of the DP2 antagonist fevipiprant. After 12 weeks, fevipiprant markedly reduced airway inflammation and improved patients' lung function and quality of life. Our positive results led to fevipiprant being accelerated into Phase 3 development.
By doing the research, I'd feel so much better. The specialists that are involved, they just treat you so great. They all know so very much about asthma that it makes you feel so much better. To actually think that I'm on the treatment that I'm on, that isn't out there for anybody else, I just feel superb.
We recognise that treatments for asthma and COPD are not one size fits all, and we need more personalised therapies. This precision medicine approach is exemplified by the anti-DP2 study that benefited asthma patients with a particular inflammatory profile. This follows on from major successes in Leicester, such as the licensing of mepolizumab, the first new class of therapy for asthma in 15 years.
Our BRC will use our infrastructure to extend the breadth and scope of our experimental medicine research to improve the lives of patients.